Hello and welcome. In this lesson, we will explore the perimeter and area of composite figures. Remember that in everyday life, most shapes that we work with or encounter are made of more than one basic geometric shape or composed of more than one basic geometric shapes. And that's the reason why we call them composite figures. And in order to find the perimeter and the area of such composite shapes, we will have to break them down or decompose them into the simpler basic geometric shapes they're made of. So, as an example, I brought in this shape. It looks like an arrow. And together we are going to go over the process of interpreting or describing how to find the perimeter and the area. So first of all, we're going to use a highlighter to highlight the perimeter of the composite shape. We kind of get to know what kind of shape we have and how are all the lines connected with each other. So it's always a good idea to start with the perimeter. There we go. So whatever you see in green makes for the perimeter of this shape. Now, in the next step here says that we need to use a pencil or a pen and draw lines to separate the shape that make up this composite shape. So what I'm going to do is I am going to draw in here a straight line because I see a triangle here. I'm going to decompose this in more than one way as well so that we can see how we can interpret this in more than a way. So we have in here the first shape, which is a triangle, and we're going to label this A1. Now, as you can see in here, this shape doesn't have a particular name, but if we drew a line right here in the middle, then you can clearly see two trapezoids. So I will highlight the first one. This is the first trapezoid. And now we'll highlight the second one. As you can see, these two trapezoids have the same size or are of the same size. So therefore, we can use the same symbol to describe them. So A2 in this case. So if we were to describe the total area, we'll say that would be equal to area A1 plus 2 area A2s. Now, when it comes to the perimeter, obviously, we will need to label each side length. And in this case, we will say that we have the sides. We can label them with lowercase letters. So these two are equal. So we're going to call both of them A. These two are equal, and we're going to call them by letter B. And then we have this side C. It's not equal to any other side. Another length that is very important here would be the length of this side, which seems to be equal to the length of this side here. I'm trying to move this. All right. So we're going to call them by letters. So far we have A, B, C. We can call them both D because they're equal to each other. And we also need a name for these two little sides in here. One here and one here. And this would be described by the same letter E because they are equal to each other. And I'm going to use this symbol here, and I'm going to use a triple line for these to indicate that they're equal. So when it comes to the perimeter, then we'll say that the perimeter equals, we have two side lengths A units each. And then we have 2 side lengths of 2B. And then we have 1 side length C. And then we have 2 side lengths each B units, D units. And then we have these 2 little side lengths, which are each E unit. So 2E. And if you want to find the perimeter and you had the numerical values, then you could substitute and find the actual value of the perimeter. Now, I know you're probably wondering about this side. This is not part of the perimeter. And this is what we're going to do right now. I will be erasing the way I decomposed this shape before. And you can see that there is no side in between here. Okay, so that's why we simply had the 2 side lengths E each. So another way of decomposing this shape would be this. So I would see in here this triangle and then this triangle. They're both equal. So I can call them both by the same symbol, A1 and A1. And then the next shape would be the shape of this rectangle. And I would call this the shape A2. And the last one would be the shape of the triangle here. So again, as we were discussing before, different ways to decompose the shape here, right? So we're going to say that the area total is equal to 2A1s plus A2 plus A3, right? So let's get started now to practically find the area and the perimeter of some particular shape. So we're going to get started with example number 2. So we're trying to find the perimeter and the area of this shape in here. So examine the shape first. So what I see here is a trapezoid. Okay, but then this part of the trapezoid is cut off and it seems that this part is a half circle. So I will highlight the perimeter. Oops. Okay. And I'm going to do this for this portion of it. Okay. And we are going to get started with the perimeter. So the perimeter of this shape is made of the following lengths. So as you can see in here, we have this length, 7 centimeters, equal to 7, and this base is 16. So that tells us that this trapezoid is isosceles. Remember, isosceles means 2 equal sides. So that means that to find the perimeter, we need to add all the lengths, but we need a name because we need to communicate the solution properly. So we have AA for both sides, for each side in here. They're equal, so we use the same letter to describe them. And then we have the base of it, which is 7 plus 16 plus 7. And that would be equal to 30 centimeters. And the next thing that we need to take care of is this half circle. So if this side is 16 centimeters, then this will be 16 as well, which will make the radius of the circle equal to half of 16. And half of 16 equals 8. So I'm trying to stay in this a little. So the perimeter then would be equal to A plus 30 plus, remember that here we have only half of the circle with radius 8. So the circumference of the circle would be 2 pi r, but then because we have half of it, divide by 2. So then we have 2a plus 30 plus pi r. Where now, and one thing that we probably noticed already is that we don't know the value of a as of yet. And we already figured out the value of r. Sorry. And we're going to say that r equals 16 divided by 2, which is 8. And for a, we have a little bit of work to do. So if you look at the diagram, see that a is one of the sides of the trapezoid, but you can also say that is one of the sides of this triangle. And this is a 90-degree angle. So if you look at a in this particular triangle, then we're going to think, oh, so a is not just the side of the trapezoid. We can also look at it as the hypotenuse of this triangle. I really don't like how I drew this particular triangle. Let me try to do a better job here. Okay, and with a being a hypotenuse, then we can say that a squared equals 30 squared plus 7 squared, or 900 plus 49, which is 949. So therefore a would be square root of 949. And the square root of 949 is about 30.8 units. So now we have the values of a and r. We can go ahead and find the perimeter. So 2 times 30.8 plus 30 plus pi times 8. Perimeter equals, so use a calculator. So 30.8 will be multiplied by 2, add a 30, and add 8 times pi. And that gives 116.7. And that will be in centimeters. And I will box this up here. Now, the next thing we want to do is find the area. Now remember that the area was the area of the trapezoid, we said, but we have cut out a circle. So we're going to call the area of the trapezoid by letter A1. And we're going to call the area of the semicircle or half circle by A2. So the total area would be equal to A1 minus A2. Now A1 is, remember, trapezoid formula is the average of the two bases multiplied by height, and then done. So 30 plus 16, divide this by 2, and then times the height, which is 30. So as I said, average of the bases times 30. Now we are taking away area of the circle, pi times 8 squared, but not all of it, just half of it. So pi 8 squared over 2. So use the calculator to find the value. So 30 plus 16 is 46. Divided by 2 is 13. 23, sorry. And then times 30 minus 64 pi over 2 is 32 pi. So 23 times 30 minus 32 pi equals 589.5. And that would be in centimeters squared. And that would be the answer. Okay, so this is how we would go around finding the area and the perimeter of this particular composite shape. So I've brought another example here. This is a little bit longer. Again, as always, if you would like to, you can just stop and try to do this on your own. If not, let's continue together. So in this shape in here, we have the design of a miniature golf course, and we want to find the total area of it. So we're focused only on the area. So this is kind of nicely broken down for us, so you can tell that the shapes that we see here are this right angle trapezoid. It's called a right trapezoid, and we'll call this by A1. And then we have this trapezoid, and please pay attention to these little lines in here. So we're going to go over it together. Just give me a second. I want to highlight it. Didn't do a really great job, but okay, now it's better. So, and I will call this A2. Now, a few things that I want you to pay attention to. You see these arrows? It indicates that these two sides are parallel, which it indicates again that this is a trapezoid. And you see these short little lines in here. That means that this side here is 2.5 meters as well. Now, similar to this, you probably noticed that there are arrows in here as well. So that indicates these two are parallel, and a square, which indicates that's a 90-degree angle. So the next shape that we see in here is the shape of this rectangle. And the rectangle here is measuring 4.6 by 2.5. These two sides are equal, and these two sides are equal. We're going to call the area of this rectangle A3. And we have one last shape to include in our calculations, which is this half circle, and we'll call this A4. And we'll say that the area total equals A1 plus A2 plus A3 plus A4. Now, it is very important that all these A's that you're using here, A1, A2, A3, and 4, in the formula, they need to be put on the diagram as well, so that we can make a connection between the solution and the information we're using. So, there are two options. One option is by substituting each area into the total area and then simplifying the equation and finding the area, or you can work on them one at a time. I'm going to work on each area one at a time here on the side. So we have area A1, which has the basis 2.1 and 1.2. So we'll write 2.1 plus 1.2 divided by 2 multiplied by the height. Here is the height of it because the angle is 90, and that's times 2.3. And do all the calculations in one step. Be very careful that when you use the calculator though, if you want to do everything in one step, we got to keep the numerator in brackets. So let me just make it more clear here. So brackets, and then you have to press divide by 2 and then multiply by 2.3. So 2.1 plus 1.2 divide that by 2 and then multiply by 2.3 gives 3.795. And that would be meters squared. So we're done with A1. We'll continue with A2. It's another trapezoid. And I'm going to write down below. And what we see in here in this trapezoid is the two bases, 4.6 and 1.8. And we do not know what the height is, so that means we have a little bit of work to do in here. And I'm going to start off by dropping the height from the shorter base onto the longer base. And I'm going to make it clear that's the height by drawing a little square in here. And I'm going to mark this by letter H. And I have to do some calculations in here. So in this right angle triangle, I know this side 2.5. I know this angle, which is 90, but I don't know this side. So I'm looking at the other side of this triangle. Oh, that's the same thing. That's 2.5 because it's isosceles, right? These two angles must be equal to each other. And if I drop the perpendicular right on the base, it means that from here to here would be exactly 1.8. So to determine the height, all right, so we're going to use that triangle. So one side is 2.5, and this side here would be 4.6. Take away 1.8, and then divide by 2. And the reason why is because from 4.6, we are taking away these two lengths. We're taking away the 1.8, this length in here, and then divide by 2 because we have two such lengths. So 4.6 minus 1.8 divided by 2 equals, let me double check here. So 4.6 minus 1.8 is equal to 2.8. Divided by 2, that's 1.4. So we're going to say that h squared plus 1.4 squared equal 2.5 squared. So 2.5 squared is 6.25, and 1.4 squared, I think, is 1.86. And that's 4.29, and if you square root 4.29, is 2.07. So now that we have the height, we can find the area of it. So that would be the base of 4.6 plus the other base 1.8, divide by 2, multiply by the height, which we found out to be 2.07. So use a calculator, and 4.6 plus 1.8 over 2 times 2.07. And the answer I got is 6.624. So I will round it to 6.624. 6.6 would be sufficient enough. And that would be in meters squared. So the next shapes that we see in here are shapes A3 and A4. So A3 is a rectangle, and the area of this rectangle would be length times width, or 4.6 times 2.5. And 4.6 times 2.5 equals 11.5. And that would be in meters squared. The last shape, A4, is the shape of a semicircle, which is pi r squared over 2. And the radius would be equal to 2.5 divided by 2. And 2.5 divided by 2 is 1.25. So we have pi 1.25 squared divided by 2. So pi 1.25 squared divided by 2, I got 2.45. And that would be A4, everyone. So the total area now equals 3.795 plus 6.6 plus 11.5 plus 2.45. So add them all together. I am using the calculator for this. So plus 11.5 plus 6.6 plus 3.795. I got 24.3. And that would be in meters squared. And that's total area. And that's the end of the lesson. And I hope the lesson made sense and it helped you to better understand how to find perimeter and areas of composite shapes. Thank you for listening, and bye for now.